There were the spectacular results of the Ranger and Mariner missions, and the other significant accomplishments which advanced our programs toward their objectives. These objectives are to explore the moon, the planets, and the interplanetary environment of our solar system, to investigate the sun and its relationship to Earth, the geophysical properties of the Earth, and the physical nature of the universe, to determine the biological effects of the space environment on Earth life forms, and to search for and analyze extraterrestrial life. To develop experiments for manned space flights which use the special capabilities of the trained astronaut as a sensor, manipulator, and evaluator. To provide pre-doctoral training for scientists and engineers, and grants for space science research projects and laboratory facilities to best use university resources for the national space effort. To develop and manage launch vehicle systems on which reliable space transportation for all payloads depends. To conduct research and development on meteorological satellite systems and support the Weather Bureau in applying them to an operational system. To develop and apply space technology to other practical satellite applications, such as communication and navigation. In April 1965, one accomplishment in communications was the NASA turnover of SYNCOM-3 and SYNCOM-2 to the Department of Defense for their operational use. The basic engineering data planned for them had been largely collected. SYNCOM-3 was launched in 1964 and maneuvered into the world's first stationary orbit at an altitude of about 22,300 miles over the mid-Pacific. SYNCOM-2, launched into the world's first synchronous orbit in 1963, was moved in 1965 to a new station above the Indian Ocean. Now both communications satellites are serving the Department of Defense for voice and teletype to Southeast Asia. Experiments in air-to-ground communications by satellite were successfully conducted in January between a ground station and a Pan American Airways aircraft in flight over the Pacific. The two-way airborne terminal communicated via SYNCOM-3 with the California ground station from a position as far away as Hong Kong. And also in 1965, communications for Gemini manned space flights were routed through the SYNCOM-3 spacecraft. Early Bird, the first commercial communications satellite, was launched by NASA in April for the Communications Satellite Corporation on a reimbursable basis. The payload was a direct outgrowth of SYNCOM developments. The first Early Bird inaugurated live transatlantic programs in April. It also made possible the live television transmission of the Gemini 6 and Gemini 7 recoveries from aboard the carrier Wasp. This used the type of transportable ground station first developed for NASA's communication satellite program. In 1965, the first prototype model of an applications technology satellite was produced under the direction of Goddard Space Flight Center. This program is a major NASA effort in communications, navigation, and meteorology. It is concerned with the advanced technology of gravity gradient and spin-stabilized orientation systems. It will also be used for antenna research and the determination of environmental effects on components. Technology experiments for the first flights have been selected, and initial flight is scheduled for 1966.